How do you work with aggregates that have large nested collections that can grow exponentially when using domain-driven design? I'm going to show you how this is a problem and what are some ways that we can solve this. We're going to implement a feature for removing a line item from an order, and we're going to discuss what are some potential problems that could arise. So let's go ahead and create a feature folder, which I'm going to call remove line item, and we're going to create a command and a command handler inside. So for the command, I'm going to call it remove line item command. And from the arguments, it's going to only need the order ID and the line item ID. Let's make it into a record and give it the properties that I just said. So order ID, and let's give it the corresponding name and line item ID. All right. And I'm going to need to implement the iRequest interface coming from mediator so that I can use this in a request handler. I'm going to use the non-generic version. And now let's add the remove line item command handler. So remove line item command handler. We're going to implement the iRequest handler interface, and we're going to specify our remove line item command. And let's go ahead and implement this interface. Now I'm going to inject my application DB context interface so that I can use EF Core to load my aggregates. And then we're going to discuss what are some of the pain points that we could run into. So I'm going to create a private read-only field that is going to contain our iApplication DB context, and let's give it a name of context. I'm going to inject this from the constructor, and let's see how we would implement the handle method. I'm going to make it asynchronous, and the first thing I need to do is I need to load the order into memory and then decide how I'm going to remove the line item. So I'm going to say order, and let's load it by calling our DB context. So we need orders, and we can call the find async method and specify the order ID coming from the command. I can also pass in the cancellation token if I want to. And now we need to figure out how we can remove the line item. We need to tell EF Core to load our line items when we are fetching the order by the ID. So to do that, we're going to say, when we call the orders property, we need to say include, and we need to tell EF Core to also include the line items when fetching the order. The problem is that this now returns a Nike variable, and we can no longer use the find async method, so we can call either first or default or single or default, and in this case the more correct version would be calling single or default, because we can only have one order with the given ID, but the downside is we need to write the expression. So I'm going to say that the order ID is equal to the order ID coming from our command, and we can also pass in the cancellation token. What we need to do now is to call order and say remove line item. So let's say we had a method like this, and we can pass it the line item to remove. Now I don't have this method implemented, so I can create it quickly on my order entity. So let's say we are accepting a line item ID, and what we do is we try to fetch the line item with a given ID. So we can say line items first or default, where the ID of the line item is equal to the line item ID passed into the method. And let's say this is the line item variable. And now if this is null, we can return. So let's say if line item is null, we can just return. Otherwise, I want to say line items remove line item. So this implements our remove line item method. And now if I go back to my command handler, you can see that now I'm getting a complaint that the order may be null because I called the single or default method, which could return null. So to solve that, we can just add a simple null check here that if the order is null, let's go ahead and return. So this is supposed to be is, not in. Awesome. And after all of this, I can say context save changes async, and we're done. So we implemented the remove line item feature, but could we have done something better? What I'm talking about is this part here, where we are loading the entire line items collection into memory, only to be able to remove a single line item in the remove line item call on the order. This is a common practice with domain-driven design, where you have to load your entire aggregate from the database In our case, the aggregate is the order entity containing the line items. But it's inefficient because we don't need the entire aggregate to be able to perform this operation. Imagine that you're working in a specialized e-commerce system where the orders can be very large and you have tens or hundreds of thousands line items on a single order. You can see how this is quickly going to slow down the entire application if we are loading all of the line items together. The next problem is if the line items have some sort of relationship attached to them. This can easily cause Cartesian explosion and your EF queries are going to blow up and simply throw an exception. With recent EF core versions, we have support for split queries, and to run a split query, you just need to append a call to asSplitQuery. So what's going to happen with split queries is EF won't convert this into a join, which would be select from orders and then join on the line items. It's going to actually run two separate queries, one to fetch the order and another query to fetch all of the line items. This is actually optimized because if the first query returns null, the second query for fetching the line items won't be executed. But this still doesn't solve the problem that we have of fetching all of the line items from the database. So what you can do is, let's get rid of this split query here, and we can do what's called a filtered include. So inside of the include statement, you can also write a where expression. So with this, I can further filter the included statement, in this case the line items, and I can say return only the line items matching this expression. And what I can do is I can match a line item by the ID from my request. So with this version, we are now only going to load the order with the specified ID, and then we're going to load the line items with a filter applied. So we are only going to return the line item with the ID that we specified here. So the end result is we only load one order object into memory and one line item object into memory. And this is exactly the line item that we want to return from our remove line item method. So you can see how this is much more performant than loading all of the line items from the database, but it comes at the cost of breaking the aggregate constraints because we are not loading the entire aggregate into memory when we want to complete this operation. What do you think about this approach? My opinion is that we should be more pragmatic when implementing our application features, even when applying domain-driven design principles. In this case, we do not need to load the entire aggregate into memory to be able to perform a simple operation. We are definitely making a trade-off here, but we are doing it in favor of performance, and I think this is a good decision for most of the applications out there. Also, make sure to smash that like button for the YouTube algorithm, subscribe to my channel for more videos like this one, and until next time, stay awesome.